Imagine a world, not so long ago, where a simple scratch from a rose thorn could lead to a fatal infection. A sore throat could be a death sentence. This was the reality before the 1930s, the pre-antibiotic era. Hospitals were places people often went to die, not to be cured, because doctors had no effective weapons against common bacterial infections. A tiny, invisible enemy could bring down the strongest person. But in a cluttered London laboratory, a single, messy accident was about to change the course of human history forever. Our story begins in 1928 with a Scottish scientist named Alexander Fleming. He wasn't the tittiest person, and his lab at St. Mary's Hospital was famously disorganized. He was studying Staphylococcus, a type of bacteria responsible for everything from boils to fatal sepsis. Before leaving for a 2-week holiday, he had left several petri dishes with bacterial cultures on his workbench. It was a seemingly insignificant act, something he'd done 100 times before. But this time, fate had a different plan. When Fleming returned to his lab on September 3rd, he began sorting through the stack of old dishes. Most he just tossed into a tray of disinfectant. But one caught his eye. Something was different about it. A splotch of bluish-green mold, similar to what you might find on old bread, was growing in a corner. That wasn't unusual. Contamination happened. But what was astonishing was the area around the mold. It was clear. The powerful Staphylococcus bacteria, which should have covered the entire dish, had been completely destroyed wherever the mold was present. It was as if the mold had created an invisible barrier, a zone of death for the bacteria. Another scientist might have simply thrown the contaminated dish away, annoyed at the ruined experiment. But Fleming was curious. He looked closer, his mind racing. He famously said, "That's funny." It was the ultimate understatement. He realized this wasn't just a ruined culture, it was a phenomenon. This mold was producing something, some kind of juice, that was lethal to bacteria. This was his eureka moment. He carefully took a sample of the mold, which was later identified as a rare strain of Penicillin notatum. He had stumbled upon the world's first natural antibiotic. Fleming named the active substance penicillin. He was convinced of its potential. He spent the next few years trying to isolate this miracle molecule. He conducted experiments showing it could kill a wide range of harmful bacteria without harming human cells. The problem was, penicillin was incredibly unstable and difficult to produce in anything more than tiny quantities. Imagine trying to extract a single drop of perfume from a ton of flower petals. It was a frustrating, painstaking process. He published his findings in 1929, but the scientific community was largely unimpressed. For over a decade, Fleming's groundbreaking discovery remained a laboratory curiosity, a brilliant idea that couldn't be put into practice. The world continued to suffer from bacterial infections, unaware that a potential cure was languishing on a shelf. Then, everything changed. The world plunged into the darkness of World War II. Suddenly, the need for a drug that could treat infected wounds on the battlefield became desperately urgent. Millions of soldiers were dying not from their initial injuries, but from the infections that followed. The British government began pouring resources into medical research, and Fleming's forgotten paper was rediscovered by a team of brilliant scientists at Oxford University. This team was led by the remarkable men Howard Florey, an Australian pathologist, and Ernst Chain, a German-Jewish biochemist who had fled the Nazis, along with their colleague Norman Heatley. They picked up where Fleming had left off. They were determined to turn penicillin from a lab curiosity into a life-saving drug. Their work was intense, conducted under the constant threat of air raids. They started with bedpans and milk churns, anything they could find, to try and grow the mold in larger batches. Their initial successes were small, but powerful. They managed to produce just enough to treat their first human patient in 1941, a policeman who was dying from a severe infection. The penicillin worked miracles, but their supply ran out, and he tragically relapsed and died. The experience was heartbreaking, but proved the drug's potential. They knew they had to make more. Realizing they couldn't produce enough in war-torn Britain, Florey and Heatley made a perilous journey to the United States in the summer of 1941. They carried with them not secret documents or weapons, but spores of the Penicillium mold, smeared into the lining of their coats to keep them safe in America. They collaborated with government labs and pharmaceutical companies. A nationwide search was launched for a more potent strain of the mold. The winning sample was found on a cantaloupe melon in a market in Peoria, Illinois. This new cantaloupe mold, combined with new fermentation techniques, finally cracked the code for mass production by D-Day in 1944. There was enough penicillin to treat every single Allied soldier wounded in the invasion. The age of antibiotics had truly begun. The impact was immediate and revolutionary. Soldiers who would have certainly died from infected wounds were saved. It was hailed as a wonder drug. After the war, penicillin became available to the public, transforming medicine forever. Diseases like pneumonia, syphilis, gonorrhea, diphtheria, and scarlet fever, once terrifying killers, were now treatable. Surgical procedures became much safer. As the risk of post-operative infection plummeted, childbirth became less dangerous for mothers. Life expectancy soared. It's no exaggeration to say that penicillin has saved hundreds of millions of lives, more than any other drug in history. In 1945, the Nobel Prize in Physiology or Medicine was jointly awarded to Alexander Fleming for his initial discovery and to Howard Florey and Ernst Chain for their monumental effort in developing it into a usable drug. Fleming, ever humble, always emphasized the accidental nature of his discovery. "I did not invent penicillin," he said. "Nature did. I only discovered it by accident." The story of penicillin is a perfect storm of luck, curiosity, and perseverance. It's a testament to how a single moment of observation in a messy lab, followed by the dedicated and heroic work of a team of scientists under immense pressure, could fundamentally change the world. It ushered in a new era of medicine and gave humanity one of its most powerful tools against disease. It's a powerful reminder that sometimes the greatest discoveries come not from a grand plan, but from a little bit of mold and a scientist who decided to look closer. Thanks for watching. If you found this story as amazing as we do, don't forget to like this video and subscribe for more incredible stories from the history of science. See you next time.